Welcome to question 7 of the 2019 Mathematical Methods Exam 1 for the Southern Hemisphere. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAR. For question 7, the graph of the relation y equals the square root of 1 subtract x squared is shown on the set of axes below. P is a point on the graph of this relation, A is the point -1, 0, and B is the point at x, 0. For part A, we want to find an expression for the length of PB in terms of x only. So PB is this length here, which is simply from 0 to y, so it's just going to result in y. And we know that y is simply equal to the square root of 1 subtract x squared. So therefore, PB is equal to the square root of 1 subtract x squared. So that is the answer to part A of this question. From the examiner's report, we can see that only 58% of students got this question correct. And the examiner goes on to say that though mostly well done, some students left their answers as an incorrect and unsimplified form of the distance formula. So a longer way of approaching that would have been to calculate the distance between 2 points. And unless simplified, you wouldn't have gotten full marks for that question. So it was easier to just identify that that length was just the y value of the point P. For part B of this question, we're asked to find the maximum area of the triangle ABP, which is shown on the diagram to the right, and it's the shaded triangle or the shaded area that we're looking to maximize. So the first thing I'm going to do is I'm going to find an expression for A of x, which is the area as x changes of that triangle. So it's a triangle, so we know it's going to be a half times the base length, which goes from -1 to b, so this length here that I've just done in purple. So it's going to be 1 plus x is going to be its length. So we're going to have a half times 1 plus x. And then it's going to be multiplied by the height, which I'm just doing in orange here, which we already knew had an expression of 1 minus x squared. So not that it's an answer to this question, but I am going to put a box around that because we'll be coming back to that time and time again. Next, if we want to find the maximum possible area, we're likely to need calculus to do that. So what we're going to do is we're going to differentiate this, so we're going to find a dashed of x. And to do that, we can see that it's actually two functions multiplied together, so we're going to need to use the product rule. So next, if I set up the product rule down here, I'm going to let u be one of the functions that's multiplied together. And for now, this constant that multiplies out the front, this half, we're just going to leave it, and I'm going to hone in on 1 plus x as u. So u is going to be 1 plus x. And then the second function is going to be v, which is equal to 1 subtract x squared. And instead of having the square root, I'm going to rewrite that as a power of a half. Next, we want to calculate du dx, and that's going to equal 1. So the derivative of 1 plus x is just 1. And then we also need to calculate dv dx, which is going to be a chain rule. So we're going to take the power out the front, 1 off the power, so that half comes out the front. And then we still have 1 minus x squared in there, but now to the power of -1/2. And then we multiply that by the derivative of the inner, so 1 minus x squared just differentiates to -2x. And then if I just clean this up slightly, the half and the multiplied by 2 will cancel. So we're actually just going to have minus x on the top line divided by, and this -1/2 takes it down to the bottom of the fraction. And the half reintroduces a square root, so it's going to be -x divided by the square root of 1 subtract x squared. Now to complete the product rule, we're just going to multiply u by dv dx and v times du dx and add them together. So therefore, a dashed of x, and this is where we can't forget about that half that was already there, so I'm going to put a half out the front and then a big set of brackets because this will apply to all of the calculations we do. It's going to be 1 plus x multiplied by, and then it's -x divided by the square root of 1 subtract x squared. And then we're going to add on to that v, which is 1 minus x squared to the power of a half, which I'm just going to rewrite as being the square root of 1 minus x squared for this. And then that's technically multiplied by 1. And now to proceed, we actually want to combine these terms with a common denominator. So we can see the first term will end up with a denominator of the square root of 1 minus x squared. So this second one, we want to get the same denominator there. So essentially this multiplies by 1. I'm just going to erase that because that's not going to change anything. So then to get our common denominator, we're going to multiply by a fraction that's equivalent to 1 with the correct denominator that we're looking for, which is the square root of 1 subtract x squared. So we put that on the top line as well. So therefore, rewriting this with a common denominator, we'll have a dashed of x is equal to, and we'll still have our half, multiplied by, and our common denominator, if I put that in first, is going to be the square root of 1 subtract x squared. And then on the top line, we're going to have 1 plus x times negative x, which will actually give negative x squared minus x. And then we'll have the square root of 1 subtract x squared times the square root of 1 subtract x squared. So the square roots, when we multiply those two things together, will actually just give us what's underneath. So that's just going to give us plus 1 minus x squared in there. And then what we're going to want to do is we're going to solve this equal to 0 to find a stationary point that hopefully represents the maximum possible area. So the important thing here is if we're solving an expression that's a fraction equal to 0, it's really just the top line that can equal 0. Because if the bottom line equals 0, then it's undefined. So therefore, what we're actually trying to solve is going to be the top line equal to 0. And we have minus x squared and another minus x squared there. So this is actually minus 2x squared minus x plus 1 equals 0. And now to help solve this, we're going to take the minus 2 and multiply it by the 1. So that is the coefficient of x squared is minus 2 times the constant term, which is 1. So we look for the factors of negative 2 that add up to negative 1. So we could have negative 1 and 2, or negative 2 and 1. So we're going to use the second pair to split up the middle term. So therefore, we've really just got minus 2x squared minus 2x plus x plus 1 equals 0. And then we're going to factorize the first two terms together with the highest common factor of minus 2x, leaving behind x plus 1. And then we can see the next term, the highest common factor for that is 1, leaving behind x plus 1. And that, of course, is still equal to 0. And then we can factor out the x plus 1, leaving behind minus 2x plus 1 equals 0. And then applying the null factor law, we say that x could equal negative 1, or we could have x is equal to positive 1/2 as the two possible solutions. Now, if we choose x equals negative 1, there would be no area to that shape. So it must be x equals 1/2 is the value that's going to maximize the area. Next, we're going to use the area function, which was in the box up above just here. And we're going to plug x is 1/2 into it. So a of 1/2 is going to equal 1/2 times 1 plus 1/2 times the square root of 1 minus 1/2 squared. And now we just need to simplify this, and that will give us the maximum area. So therefore, a of 1/2 is equal to 1/2 times, and 1 plus 1/2 is 3 on 2. And then that's going to be multiplied by the square root of 1 minus, and 1/2 squared is 1/4. So 1 minus 1/4 is 3 on 4. So therefore, a with x is 1/2 substituted in is going to be 1/2 times 3 on 2 gives 3 on 4 times, and then the square root of 3 has to stay as the square root of 3, but the square root of 4 can be turned into a 2. So therefore, the maximum area when x equals 1/2 is equal to 3 root 3 divided by 8. And then we don't have a unit, so we could just write unit squared there. So that is the answer to part B of this question. From the examiner's report, we can see that only 15% of students got this question fully correct, with 41% of students receiving 0 marks and about a third of students getting 1 mark out of 2. So the examiner goes on to say that the majority of students used calculus to solve this problem. Some students did use geometry and trigonometry to obtain a correct solution. However, the vast majority did use calculus. Most students were able to find an expression for the area in terms of x of that triangle. and many of the students who used calculus found the differentiation of that expression difficult, and that was generally a result of poor setting out, particularly with the lack of brackets or dealing with the negative terms. The examiner does say that students are encouraged to practice differentiation involving a combination of the product and chain rules, which might be a good hint that down the track in future exams, those sorts of questions might pop up again.